Okay, for the third one, you also apply the same principle of differentiation from first principle. You add delta y to this side of y, then you add delta x to this side of the square root. So when you do that, you are going to get something like this: x plus delta x, x plus delta y will now be equals to, then you have your square root, which is in 2, then you need to open bracket, x plus delta x, then you go out and you have plus 7. So this is the first step and the first thing you do in all differentiation from first principle. Add delta x to the x, add delta y to the y. So when you are through with that, the next thing is you take your y to the other side. You know this is square root, there's no way we can expand this square root. If you look at the previous examples, number 1 and 2, after you have done this, you need to expand the value for the delta x plus delta x. That is the next thing. But in square root, you cannot expand square root, so you leave it like that. So our next step is going to be, let me just copy this to make it fast. So our next step now is going to be like this. So y is going to leave this place. So y is going to the other side. So, and when y comes to this side, it's going to be minus y. So that is the next step, which is this. Then after this, the next step now, the value of y, we need to substitute it there. And what is the value of y? So this is the value of y, which is the square root of this, which is square root 2x plus 7. So it's going to replace this square root 2x plus 7. See, still there's no way we can simplify this. They are not like terms. You cannot subtract, you cannot add anything because of roots. Then the next thing now, since there's nothing we can do now, the next thing we need to do now is to divide each term by delta x. So that is the next thing to do. You copy, let's just make it fast. So when we divide each term by delta x, this is going to be delta x. Then this other side, everything here is going to be divided by delta x. So that is this. So this is what we are going to get. Then at this stage, if you look at it now, there's nothing we can do again. We have applied everything we know for first principle, but we are supposed to still simplify further. Something need to cancel out. This delta x needs to leave, this denominator need to leave here. So how are we going to do this? So you now need to apply your rationalization. You need to rationalize the numerator. So let's put it in words. So if I rationalize, you need to rationalize. You know rationalization is solved. When you rationalize the numerator, you need to rationalize the numerator. With your knowledge of solve, you know what rationalization means. So when you rationalize the numerator, that means this value of the numerator is going to multiply the numerator and the denominator. Then this place is having minus, then it's going to be plus when you multiply the numerator and denominator by this value. So how are we going to do that? Let me copy this out also to make it fast. So how are we going to do that? So it's going to be something like this. So still on this place, this time around you put your times, then we are going to have the same value here, which is this same value. Let me copy this. The same value we have in the numerator, it's going to be here. Remove brackets. Let me remove this equals to, yes, so this same value, but this time around this minus needs to be plus. So that is just the only difference from the other one. Then divide by, let me arrange it well, and divided by the same value. Let me remove this from here. Okay, then this place is going to be plus. So this is how you rationalize the numerator. So this same numerator, the same value, use it to times the numerator and the denominator. Then the only difference is whenever you have your minus, change it to plus. So if this were to be plus, here will be minus. So that is the rules. So you know the rules of rationalization. So now that we have done this, now we need to expand the numerator. So the numerator, we can use difference of two squares. Since they are having the same values, the only difference is the plus or minus. So if I use my rule of difference of two squares, let me come down. If I use difference of two squares here, so I'm going to square this. So the square root will disappear, leaving 2 bracket x plus delta x plus 7 minus 2x plus 7. So we are going to get our delta y divided by delta x now be equals to 2, which is this. No, we are using difference of two squares, so you square this. So square will cancel square root, and I'm left with 2 open bracket x plus delta x plus 7 plus 7, then minus. Then in this case, you need to open bracket because of this minus. So you must open your bracket here. If you not open bracket, you may make mistake. You open bracket, you have your 2x plus 7. So that is all for the numerator. When you expand the numerator very well, so take your time. You can use your pen and your pencil, your pen and your paper to do the expansion. When you do it, you will see that this is the answer. So take time and expand it very well. While the denominator delta x will come first, so let's put it there. Delta x is going to multiply the root of this value. And what is the root? The root is 2 open bracket x plus delta x plus delta x plus 7. Then you have plus another root again, 2x plus 7. So that is that. So with this one, what next? What are we going to do next? So let's open this bracket to see what can cancel what. So if we open the bracket of the numerator, let me copy it first. So if you open the bracket of this numerator, so we are going to get this. When you open the bracket, so you have this bracket is going to leave this place. So we're going to have 2x plus 2 delta x. So 2 is going to be in this place. Plus 7, then minus. When you open this bracket, you're going to have minus 2x, and this plus is going to be minus. The plus minus is minus. So that is all. Then let's see what can cancel. You can see now when you collect your like terms, 2x is going to cancel out 2x, 7 is going to cancel out 7, leaving 2 delta x in the numerator. Then delta x will divide delta x. So that's how they will go. Leaving this, let me copy it so that we'll be fast with it. So when we do that, we are now going to have delta x will leave this, but before we do that, let's see what can go. 2x minus 2x are like terms, so this will turn to 0. 2x will go. Then 7 minus 7, 7 will also go. Then 2x will go. Actually, 2x minus 2x is 0. 7 minus 7 is 0, leaving 2 delta x. And now that it's left with 2 delta x, then delta x can cancel this delta x here. See, when they divide out, we are left with 2. So we don't need to, we'll do that in the next step. Let me not rush fast. So in the next step, let's copy it fast. So in the next step, delta x will cancel out delta x, so we don't need delta x here. So that one will go, and this also, this will go. So this is all for that. Then the next thing is to get the limit of the delta y, delta x. So when you get the limit, you set the delta x to 0. When you set delta x approaches 0, then this place is going to be the delta y divided by, okay, delta y divided by delta x. Okay, let me correct this place. Okay. Let me adjust this place. Okay, then this is delta x. So the limit of this value we have here, so this limit of delta y over delta x, when delta s approaches 0, that means when delta s is 0, you are going to put 0 here. You know, when you put 0 in this place, when you put 0 in this place, you are going to have x plus 7. I think I need to make one adjustment here. Yes, you see the denominator here, there's 2, so I forgot to put this 2 here. Very important. Let me put it. There's 2 here. Now this 2 brackets x is very important. Let's put it. So this 2 is here. This 2 is here. So when you are solving this thing, this topic, you need to settle down and move step by step. At the end of the day, when you make mistake, you will know. But when you are tracing your answers, you will see where your mistake will come from. So there's 2 here. So when delta x is 0, you see you are now left with 2x plus 7, which is the same thing. So the two roots, they are the same. So our final answer is now going to be dy dx. Dy dx. Oh, let's remove this. So dy dx will now be equals to 2 divided by, you see the roots, 2x, delta s is 0, so 2x plus 7, 2x plus 7, they are like terms. So it's now going to be 2 root 2x plus 7. So that is that. So this is the answer for the differentiation. Then because 2 can cancel 2, so your final answer for this, let's just copy this. Your final answer is now going to be, the final answer is going to be 1. This place is going to be 1 because 2 divided by 2 is going to be 1. Final answer is going to be 1 over root 2x plus 7. So this is the differentiation of that function. So when you differentiate this function, square root 2x plus 7, this is what you are going to get as your answer. 1 divided by square root 2x plus 7, and see the answer. And if you want to differentiate this function, if you want to differentiate this from basic rule, you know we are going to use function of a function. And now are we going to do it? You know this square root 2x plus 7, you are going to have bracket raised to power half. And when you multiply raised to power half with the coefficient, it's going to be 1 over 2. Then when you subtract 1 over 2 minus 1, see you are going to have minus half. Then when you differentiate this bracket, it's going to give you 2x. Just follow function of a function, you will see that you get the same result. Then at the end of the day, you are going to have 2 divided by 2 root 2x plus 7, which is the same thing we got here. And you use basic rule. So that is all. You can see first principle is not difficult. It's not difficult. Just follow the approach. I decided to give you these types of example because in differentiation for first principle, it's either you are differentiating functions of this type or you are differentiating square root. When you have square root, remember the rules. You follow the basic rules, add your delta y and delta x, take y to the other side, substitute the value, divide by delta s. Anytime you get to this place in square root of differentiation, the next thing is to rationalize the numerator. Then when you are rationalizing, make sure you take your time to do the expansion. Use difference of two squares for the negative sign. Then after the expansion, then try and simplify further. take like terms, divide what can divide, you will end up here. Then when you get to this place, the next thing is get the limit when delta s is 0, which is 2s plus 7 in the 2 bracket, and will now give us 2 root 2s plus 7. When 2 cancel 2, we are left with this. So this is the answer to that question. So that is all for these 3 questions I have here using differentiation from first principle. I hope you understand all I did. I believe you will understand first principle from following these 3 examples we did. Settle down and look at it very well, and you see that it's not a difficult work. Thank you for listening.